area times volume. What will be the area times the volume? This height, so what will be? It's this height, by the way, this height from here to here. This is, or we can say, which is the same, the area. I mean, we will be this height and this height. So what will be the height from the bottom, which is the depth? From the bottom is this, and this will be for this one. So what is this? H times A is the volume. So will be rho of the fluid, G volume, but is the volume. So if I said H from the bottom minus, let me just see, assuming that it's the same area to simplify this. So will be rho G times area times H from the bottom minus H from the top. So we know that this area times this will be the volume of the fluid displaced. So rho, gravity, volume of the fluid displaced. If we interchange this, what is this? What is rho of the fluid times volume of the fluid? The weight or the mass. The mass of the fluid times gravity. So what is the buoyancy force then? Is equal to what? To the weight of what? The weight of what? This is fluid. The weight of the fluid displaced by the object. So this is the Archimedes principle. So what said Archimedes? Archimedes said that the buoyancy force is the force from the bottom minus the force from the top. That's one definition. But if you do the formula, you will come to the conclusion that those two forces, subtraction, will be the same than the weight of the fluid displaced. What is the meaning? Imagine that I have this object. I put water here, so you know that the water is right there. So now, if I immerse this here in water, I can collect the amount of water that this displaced. If now I go and I go to a scale and weigh the amount of water that is here, not the container, just the water, this weight of this water is equivalent to the buoyancy force that is lifting that object. Does it make sense? So, as a conclusion, you don't need to know the proof. What you need to know is that the Archimedes principle is the buoyancy force on the objects. The buoyancy force is the force from the bottom minus force from the top. That is equivalent to the rho of the fluid, volume of the fluid displaced. I am very, putting emphasis on that. It's not the whole water. It's the water, amount of water displaced by the object, which you saw there. Time the gravity, which this is equivalent to the weight of the fluid displaced. But if by any chance you immerse completely in water the object, what will be the volume of the water displaced? The volume of the object will be equal to the volume displaced when the object is completely submerged. The object has to be completely submerged. This is very important fact, when it's completely submerged. Another important thing in buoyancy is when we have an object in a container, let's say in water, and it's partially submerged or submerged completely, but it's in equilibrium, it's at rest, what forces are acting on the object? Buoyancy, which is due to the change in pressure from here to here. That will be called buoyancy force. It's like when we did the free body diagram before, normal force, but now in the fluid will be buoyancy. What another force is acting? The force of gravity. ATM is a pressure. That is the atmospheric pressure. So on the object is acting, but remember that the atmospheric pressure is also here acting. So on the object is acting the weight. If this is in equilibrium, which Newton law you apply? The first. So sigma F has to be equal 0. Yeah. Meaning what? What will be the condition for buoyancy or for floating? What will be the floating condition? Condition to float. What will be? The buoyancy force has to be greater or equal than what?
mg.
Than mg. This is the condition for buoyancy. So, the buoyancy force, in order to float, the object, the weight, have to be less or at least equal than the buoyancy force. For this reason, when we have, let's say, the balloon, right? The helium balloon, those, how you call them, blimps. So when you have that, why that is floating in air? What is helium is lighter, then the helium and the load in general is lighter, the buoyancy force on that is greater than the weight.
The buoyancy force is only fluids, right?
Hmm?
There's no buoyancy
There is a
force
fluid.
there, right? It's only fluids, right?
There is a fluid, right?
Where? No, it's the fluid, the fluid that is displacing the weight of the helium, which is the balloon, right? So the buoyancy force, which is the weight of the air displaced, is greater than the balloon.
I was asking if there's also buoyancy force in the air. Is it only in fluids?
No.